So hello and welcome again. Basically, this is for the benefit of all of those folks who are watching this online. Thank you very much for joining us. To everybody here, welcome. Google Developer Group's Milton Keynes took a little bit of a hiatus over the last couple of years because of COVID. Obviously, we wanted to kickstart things all over again just to make sure that everybody had a chance to be able to meet and greet and see each other all over again. I know there's plenty of developers and people involved in tech in and around the Milton Keynes and Buckinghamshire and Bedfordshire area. So there's plenty of people out there, and well done for those who've come today, because you've made that first start to kind of kickstart things back again after COVID had hit. So what we're going to be doing today is we're going to be giving you a bunch of talks. Some of them are done by some developers from my company called REAS Group and KonnekApp. And we also have a talk from someone from Aiimi, which is an artificial intelligence development company, and they're based here at 100 Avebury Boulevard in Milton Keynes. Okay, so just to get things kick-started, for those of you who are watching this live, well done for getting on the YouTube. You can also download and access all of the presentations as well on KonnekApp, which is available on the Google Developer Group meetup site. Just click in there, click the link, and if you've got an Android or a mobile iOS device, please download, install it, and you can watch the whole thing, and all of the presentations as well are there. Okay, so without further ado, let me just bring on my first speaker today. Her name is Ajeet Kaur-Sucha. Ajeet actually is the first person I hired at REAS Group, and this was just at the beginning of 2020. I remember we were sat in a coffee shop, and I said, "This is my vision. This is my kind of dream. Can we work together and make this kind of thing happen?" And I remember, thankfully, she said yes. And then afterwards, like 2-3 months later, then COVID hit. So it was like, whew. But out of that, we still managed to now have 11 people working for us, and they're working for us across the globe as well. So without further ado, Ajeet, please take it away.
Thank you. So I'd kind of written out a couple of plans on what I wanted to talk about. He was talking about going into sort of 360 video, as I mentioned, software, how to grow his current client base. So I'd kind of looked into these things and presented them to him. Then I've got my Welcome to REAS Group LinkedIn post that he put up. It says welcome to the team, but it was only him before that. So I think the two of us kind of made it a team. And then the two photos on the board, well, we like to call it our first office, but really it was the John Lewis Cafe where we used to go, and we'd kind of work our day from there because we didn't have office space at the time. On the right there, I'm trying on a VR headset. So as I mentioned, Rob specialised in 360-degree video, which I'd never actually seen before, and it was a really cool experience being immersed in it with that headset. And then the picture on the left is us winning a new client, and that client's still with us today, so we must have done something right. And now, so when I joined REAS Group, I was exposed to so many different parts of a business. I wasn't limited like I was before. I think I kind of asked for more responsibility at my last role, and I think I got given all the responsibility in this role. So it was brilliant because I feel like I thrive with a little bit of pressure on me. So it definitely motivated me. On the board, I've got some of the candidates that I've had a hand in hiring. So as I mentioned, I've had a go at a lot of different things. So from website creation to procedure writing and relationship management, both client and internal, and then recruitment as well. So all those different candidates on the board have a range of different technical skills, from sort of front-end developing, media production, graphics artists, back-end developers. And I think what I realized from the way that I was hired was that Rob took a really unique approach. He made sure that it was quick, it was innovative, and also he focused not only on what skills I had now, but what my potential was in the future, which is what I wanted to focus on when I went to hire new candidates, because it worked really well for me. When I graduated, I had just bags of enthusiasm, and I might not have been able to build a website in that moment, but when I joined REAS Group and I looked into how to do it, I was then able to do it. So I think the unique kind of outlook Rob had, it made me want to have the same when going to recruit. So we realized REAS Group has 4 values, so we put these in place. It's trust, respect, support, and inclusivity. And those values don't really work unless each and every one of us upholds them to create that culture. So when we went out to kind of interview, or be it an interview or a job ad, we kind of tried to make sure that it was innovative, and we wanted to attract out-the-box thinkers, so we had to ourselves give an out-the-box kind of approach to it. So that being said, this is one of those out-the-box ideas that we had. We were trying to, so I guess I should start by saying REAS Group is broken up into 2 main parts. We obviously have the traditional media production side of things that Rob started, and now we've developed into software. So over the last year and a half, we've created KonnekApp. So KonnekApp is a marketing tool. It comprises of an app with a portal, and it's for any organization that basically wants leads and has a sales function. It allows you to upload all of your content, be that video, PDF, PowerPoint, audio, whatever it may be, onto one platform, and you can go through and you can view who's watching your content, and that serves as leads. So back then this was just an idea, so we had to create this, we had to make it real, take it from concept to something people had in their hands. So we were trying to think of what kind of team we wanted to be on that project, and we needed to hire some developers. And obviously the traditional method is you write out a job description, you post it up on sites like Indeed, Total Jobs, or Reed, and you kind of wait for the response to fall in. And yeah, we were sitting there one afternoon with Robin, our videographer, and we literally made this video within the space of like a very short afternoon. We filmed this, we edited it, and we uploaded it onto social platforms, and I'll just play it for you now.
Hi, Ajeet.
Hey.
Right, I need your help. We need a lead front-end dev.
Okay, what kind of person are you looking for?
Right, so they're going to have experience in things like React Native or Flutter or Swift, or even PWAs and AMP technologies, that kind of stuff.
Okay, cool. What about CI, CD, CV?
What the hell's that?
Rob, don't you know?
No.
Continuous integration, continuous deployment, continuous verification.
Yeah, all that good stuff. Yeah, go for it.
Okay, cool. Shall I put out an ad?
Yeah, you could do. Or actually, can you do it?
I do have to say I learnt words like continuous integration specifically for that video. So yeah, I'm by no means a tech expert. But what I was hoping to show was that you can add a bit of creative flair and innovation into anything, really. It doesn't just have to be limited to kind of traditional creative roles. So we posted this up on LinkedIn, and we've actually hired a good chunk of our developing team from LinkedIn. So yeah, I think it served really well for us, and it showed not just our it showed our personality, but it also showed that we're a fun organisation to work for. We do things a little bit differently. And again, the main things it comes back down to is our values. We have, like Lauren, our graphics artist, for example. I'm sure that there's a whole wealth of graphics graduates every year that are on the hunt for a job, and I'm sure that they can use Adobe Creative Cloud perfectly. but are they all as trustworthy, as diligent, and as meticulous as Lauren? Well, I work with Lauren, so I can vouch for her. I'm not sure about them. But that's kind of our unique approach to it. But what I'm really trying to say is that success is all about the people. The people create your company culture. They uphold it. And, you know, effective and excellent team can take just a good product and service and they can make it excellent. Social media is your best friend, and that's something I've probably been slacking on up until now. I'm not very good at social media, but our social media executive, Arzu, I think she's somewhere in the room over there, she's brilliant at it. So she's shown us in the short time that she's been here how much consistent posting can do for your business. And like I said, we've used it for recruitment quite heavily, so it's been great for us. And innovation is not just limited to traditionally creative roles. We've added it to our recruitment process, so hopefully we attract like-minded people. But yeah, there's so much more to recruitment and making sure that your team is exactly what your culture in your company kind of wants to be. And that's important as you grow. Whether you have 2 people, as Rob and I did when we started, or whether you have 50 people, everyone has to be on the same page in terms of what your company brand is. So thank you for listening. I hope that you were interested by my little journey. And please, if you have any questions, I'd be happy to answer them. Thank you.
Thank you very much, Ajeet, and thank you very much for bigging us up so much. You know, it's really great to hear about your experience as well, developing the team too. So, one of the things I was going to say as well is that just after Ajeet's presentation, there was an advert for Aiimi as well. So they're one of our sponsors for today. So if you're watching this back on live stream, please definitely check them out. I know they've got a number of different vacancies available, I believe, right, with things like a bunch of development stuff going on. So please definitely check out their job board and see what's going on there. Okay, so before I go on any further, I'm going to introduce my next speaker. His name is Ori Marash, and he is someone that I hired off of the back of a recommendation from someone from Google, actually. Ori is incredibly smart. I don't know many 18-year-olds who can say they've done a TED Talk, right? Do you? Okay, so this is the caliber of the guy. He is going to be joining us hopefully on this live stream, which we're going to try and see if we get right now. But I'm going to pass it over to Ori, and over to Ori.
Great. All right, so Waddle, you've probably heard of it before. It's kind of everywhere on the news right now. I feel like every tech talk kind of starts with an XKCD comic. So there you go. Waddle, no, I'm in the control group, kind of implying that everyone's playing Waddle right now. And since working at a tech company, I figured let's try and beat Waddle with programming. So if you haven't played Waddle before, let's walk through a quick game just so that you know what it's like. Basically, we're trying to guess some target word, and we've got 6 attempts. After each guess, we get some kind of feedback about how close our guess is to the target words. So in this case, we know that the final word won't have the letter T, but it will have the letter A in the second position, no letter B, and L and E at the end. And we can keep kind of making guesses like this and we keep getting more and more information every time that we guess, and hopefully, eventually, we'll guess the right answer and win. So we're trying to do this in as few guesses as possible. So here, 4 guesses is pretty normal if you're a mere human and not a computer. So we want to try and beat this game, right? And I hope that through kind of explaining my process through that, maybe it will show that algorithms and computer science in general is quite fun and helpful for everyday life. So one strategy that we can use is just guessing the best word every time, right? Kind of obvious. The best way that we can do that is by giving a score to each word and then picking the word with the highest score. Not anything too complicated there. In this case, we picked Konnek. The actual Konnek app has 2 N's. This is a 5-letter word. Konnek has 100 points, so we pick that amongst all the rest of the words. So the tricky part here is going to be assigning a score to each word. And we need some kind of function to do that. So let's write a function called rate, which will just randomly rate each word that we guess. So this is not going to be so great of a function. This will basically fail every game since we'll just be guessing random words. But this is just to show you the kind of work we'll be doing. So this is written in Python, by the way. We're just returning a random number between 0 and 10,000 for each guess. So this, it's not good. We'd want to do some actual calculations to make an informed guess. So how about we rate words based off how many common letters they have? So we can do that. That's that function. We're just going to kind of look at all the possible words that we could guess, which, by the way, I'm going to be getting from a Scrabble dictionary. So we look at all those words and we just count how many letters appear, like how often each letter appears. So, for example, the letter S probably appears, tens of thousands of times. Maybe the letter Q a lot less. So this rating function, it's going to return a higher score for letters that are common. So if we run this function on all the words and we check what the highest score is, then we get S's, which means the letter S, like a plural of the letter S, which I find funny because there are a lot of S's in the words. It's kind of ironic. But anyway, this isn't that great of a word because we're repeating a lot of the letters. We've got 3 S's and 2 E's, so we're only going to get really 2 pieces of information. We know whether there's an S in the word, whether there's an E in the word, but we don't know where they are in the word, if that makes sense. So one way to combat this is actually just by looking at the set of letters in a guess. So you see here, if I turn on my laser pointer, if we write a set around our guess, that means that we're removing doubles from the guess. So the word S's will only get points as if it had 1 S and 1 E. And that's a good way of kind of making sure that there are no doubles in our final guess. And running that gives us the word arrows, which, by the way, I don't think that's a real word, but it is a legal Scrabble word. Aero means aeronautical or aerodynamic, so it doesn't really make sense to have a plural of that. Anyway, we can actually do better than this word too, because we're only considering the frequency of characters in the string. But actually, we should check for their positions too. So, for example, the letter S maybe appears a lot at the end of a letter, at the end of a word, since it's a plural, right? So maybe we should rate words that have common letter placements higher. And we can do that as well. Here's a little program that does that. We basically look at all the words and count each character in a word, but we take into account their index in the word. So the index is how far along they are in the words. And we just count them all up. And then in our rating function, we kind of do the same thing we were doing earlier, but we take into account where the letter is along the words. And this is going to give us maybe a bit of a better understanding of the kind of good words to guess. Running this gives us sores, as in the plural of sore, which means an injury or a sensitive wound. Interestingly, there's a double S. Again, earlier we said that doubles aren't the best, but maybe this is actually okay, since probably an S is quite common in the beginning and the end of the words. And this is the place where things get kind of, well, sore with Waddle, and how my life was put on hold for a few days while I was interested in it. You see, there are a lot of conflicting strategies, even with a very first guess. Do we go for letter frequencies, positional placement? Do we look at pairs of letters, groups of letters, consider all of those together, give each one a rating? Like, there are so many options. It really seems like we should be using some machine learning. And although we do use machine learning at KonnekApp to generate leads from your content, I wanted to try and solve this problem with just run-of-the-mill programming. So I think one way to get a good starting guess is to use a combination of the two strategies we're using so far. And that's just here is the function that does that. And let's just walk through this. At the beginning here, oops, sorry, a little spoiler. At the beginning here, we're looking at letter frequencies along a word. So, for example, S at the end of the word is quite common. And here in the middle, we're looking at letter frequencies just in general, so throughout the entire word. And you see here, we're again considering the set of letters in a word, not the, not considering doubles, basically. And this is going to give us the word tes when we run this. So kind of a joint approach. We do get a lot of vowels, but it looks like T and S might be so common that they're considered better than vowels, which might be different to what you expect. Tes, by the way, I'm not sure if it's tes or taras, but it means a vetch, especially a common vetch, which I think is a type of plant. So there you go, you learn something new every day. So we kind of want to move on to our second guess now. Let's just leave the first guess behind. So we'll write so when we actually put this into our game, we'll get some feedback. So we get yellow in the first letter, yellow in the fourth letter there. So this isn't today's Wordle, by the way. This was from when I made the presentation a few days ago. So there are no spoilers, don't worry. So we now need another guess. And realistically, we're not gonna guess the actual word on the second try. We really need more information. So we'll make another exploratory guess. Just by using the same code we were using earlier, but we won't consider any letters that, any words that have any of the letters in taras or tes. So doing that, we get noily. So again, this is looking through all the possible words that we could enter and rating each one. And in this case, we're discarding any word that has letters T, A, R, E, or S in them. That gives noily. So noily is a white vermouth drink from France. It comes in a extra dry variety, which I find quite funny, because I'm not really sure how a wine can be dry. I can't really taste anything since COVID anyways, so whatever. So if we type that into our Wordle game, we get some more information. So you see we actually already have narrowed down. We have 10 pieces of information in what we call a knowledge base. And our knowledge base is built out of the feedback that Wordle gives back to us. So, sorry. So what we kind of want to do now is narrow down our word list, because for this third guess, we're going to go for the win. Like, I mean, we're trying to actually guess the word that Wordle has set out for us. And to do that, we need to kind of consider what are the possible words that we could be guessing. So we're going to write this function that's called isSolution, and that's going to check, using the knowledge we have so far, whether a guess is possible, like whether a guess is a solution. So that's why it's called isSolution. So this algorithm is a bit bigger than what we've looked at so far. So we can look at it in a few parts. Basically, what we're going through here is we're looking at all the information we have in our knowledge base. And we're kind of comparing the feedback we have with the guess that we're trying to make. So for example, let me put on my laser again. For example, if I have letter G, which I've just said is green. So for example, if we know that the first letter is A, and we've gotten a green feedback on that, then if the word that we're going to guess doesn't have an A in the first position, then it's not a solution. So sorry, that was a lot of double negatives, but I'll show you an explanation in the next slide. We've got more of these rules in this function. So we also check with yellow feedback. And actually something interesting here is that we can get two pieces of information from yellow feedback. We actually know that D is in the word somewhere. That's just part of the how Wordle works. But we also know that T is not in the first position. Otherwise, this T would have been green. So that gives us two pieces of information. And we also have down here a little check with black tiles. So that's just saying if it's a black character, then, so if the feedback we got was gray or black, then that's not going to be in the final solution. And you might notice I have a lot of these weird things with sets and, I don't know, adding things to that set. That's all to do with double letters. So Wordle treats double letters a bit weirdly, and it gives kind of feedback that you wouldn't expect, and that just deals with that. But really, you don't have to worry about that too much. So we've gone through this code, and yeah, so here's a little example. So if we have our knowledge base up here, and we know that A is not in the words, then isSolution apple, given our knowledge base, will return false. But if we know that A is in the first position, or in position 0, then isSolution returns true. So we run this function on all the possible words that we could guess, and that returns all of the solutions, so all the possible solutions. In the game that we were doing, this example, we have that T is in the word but not in the first position. A is not in the word anywhere. I is in the third position. That forms our knowledge base. So we're going to pop that in our function and see what our narrowed down list of words is. So remember, this Scrabble dictionary has something like 20,000 words in it. So just with 10 pieces of information, we're probably not going to narrow it down that much. So don't get your hopes up. So it actually narrows it down to 1 word. So after only 10 pieces of information, 2 guesses, we've managed to narrow down the list of options to just 1 word. In this case, elite, which is appropriate. So you might think that this is kind of a fluke, right? Maybe for other words this doesn't really work, but if we actually look at the graph of all the possible words, like I've run this on all the possible Wordle words, you can see that just with Tez and Noily, about 500 times we get 1 option remaining. So that means that we get the guess straight away, like on the 3rd guess. Here for 2 guesses, like 2 options remaining, that's something like 320 something, 330. So really, most of the time, we're going to get less than 5 words remaining. And it's something like 65% of the time, so it's actually exactly 65% of the time, we'll get 5 or less words remaining in our options list. So that kind of shows that the first 2 guesses are really, really optimal. Like, they're really, really crucial, because after only those 2 guesses, we've already narrowed down so much. So this is really where we should be putting our kind of optimizations if we work on this further. You know, if there's more Wordle academia out there, then I think that's where we should go to. But let's move on to the third guess now, because otherwise we'll never solve this Wordle. So usually we narrow this down to about 5 words. So let's say, for example, the target word is speak. Sorry, so we're just going to try and figure out how to best guess our third words. And this is the example, right? Let's say that the target word is speak. In our knowledge base, we already have the first 2 guesses. So we have information on Taures, on Noily, and that forms our knowledge base. So then when we check what the possible kind of next guesses are, we can see that it's this list of words. So speak is actually an outlier, since lots of the letters and positions that it has are quite common. It's quite a common word. So it leaves us with lots of solutions remaining. So we want to pick one of these options to guess, right? That kind of makes sense. So let's say, just for example, we pick the word shake to guess. So let's just say we guess shake. These are the possible feedback we could get if we guess the word shake. So we could get that shake is the correct words, if that makes sense. Like, it is a possible solution given the knowledge we have. So this is a possible feedback we would get that is the correct word. That narrows it down to 1 word, which is amazing. Otherwise, we have all these other guesses. All these other possible feedback we get. And then this list on the side here shows, given that feedback, what words then remain. So for example here, if we get yellow, black, green, then we'll get these 3 words left as possible solutions. There are plenty of these, so there's going to be a list here for each one. It kind of goes off the screen. But you see that actually for a lot of these guesses, except for green, right? For a lot of these guesses, we're going to have 4 or 3 words kind of still there. So we're definitely going to need another guess after this. The question is just, what's the best guess right now? How are we going to make sure that we'll guess the final words in as few guesses as possible? So this is where this gets a bit tricky, because what we want to do is narrow down the worst case. So look here at green, black, green. Here we have 4 words remaining. So if we were to get this feedback on shake, we would have 4 words remaining. And that's really bad, because let's say we got that feedback. Now we would have to guess another word, which would further narrow down the options list. Which means that we're just wasting guesses, right? It's not what we want to do. So what we should do is narrow down that worst case. And we can do that quite easily in Python. We just find the minimum words where the key is its most solutions. So what this means is we're going to look at all the worst cases for each word and find the smallest worst case. That's it. Just find the smallest worst case. And if we run this on the example that we were working on, we get champ. Again, kind of apt. And if we actually look at the same list here for champ, you can see that champ isn't actually in the options list. So it isn't a possible answer in that sense. if we guess champ, we'll never guess correctly, but it's still better than guessing one of the words that it could be, since its worst case is only 3 words. So I think that's quite interesting. Like, you don't always have to guess what you think the best word is going to be. You can just get random words to kind of narrow down your options list. And if we guess champ, if we guess champ, that will narrow down our options list a lot. And yeah, that's kind of the algorithm. So just as a summary, this is the algorithm that we just kind of figured out. So we want to get a list of all the options of words. If there's one valid solution left, we just pick that one. And then from the list of all the remaining, from all the words, not just the remaining words, all the possible words we could guess, we basically find the smallest worst case. And we pick that one, get its feedback, add that to the knowledge base, and then keep repeating until we get target words. And actually, this algorithm has already been kind of written up as a proper paper by Donald Knuth. He seems to be everywhere in computer science. He's my hero. And yeah, he actually wrote this paper up on beating a game similar to Wordle, but with colors instead of letters, called Mastermind. He wrote that probably a couple decades ago. So really, it kind of shows that problems tend to repeat themselves, but we can still apply old solutions to new problems and solve Wordles. So yeah, that's my talk. Thank you very much. And feel free to email me if you have any questions.
Perfect, let's get started. Go to the first slide. Sound like Chris Whitty. Next slide, please. Okay, so when I got the brief or the opportunity to give this presentation, I was kind of asked if I could do it on something related to a Google technology. And I thought, what better technology than their most famous of all, good old Google search. It's kind of a little bit of a play on search in general. I'm going to talk about how you can improve how you do search, and I'm going to finish with some tips and tricks for some syntax that you can use in Google search. So a little bit about me. My name's Jordan. I'm a senior data scientist at Aiimi. I joined Aiimi in 2015, straight out of university. Kind of worked my way up to a senior data scientist now. I spend most of my time building advanced analytics solutions using machine learning, artificial intelligence, ultimately to try and give insight to our customers. The industries I work across are engineering, utilities, and the public sector as well. As you can see from the slide, some of my favorite technologies, good old Python programming language. I'm sure there are some advocates in the room. And probably aptly for a presentation on search, the open source platform Elasticsearch. So if you're familiar with that, it's a really powerful search platform. So who are Aiimi? We're a technology company. We specialize in artificial intelligence solutions. Those solutions are helping bring insight to organizations that we work with. And how do we do that, you might ask? So we've got kind of two sides to our business. So Aiimi Services, that's our team of consultants, where people like me work with our customers to drive insight and knowledge from their information. And then we have Aiimi Software, where we've got a team of absolute rock stars who are building our industry-leading software platform. And I'll talk a little bit about that now. So the Aiimi Insight Engine, they've spoiled my thunder with this a little bit by showing the advert earlier at the ad break. As I say, it's our industry-leading platform. It's built for search, for discovery, for governance, compliance, and for data science, so it does a lot. And again, it's all about driving insight from our customers' data and content. So I'm going to start with a quote, and it's a quote by me. I say this regularly, in fact, almost on a daily basis, and some people in the room will probably advocate that. And the general gist is this: being able to Google things is a skill. And you might look at me and think, we all Google things every day. And hopefully by the end of this presentation, you understand a little bit about what I mean from that. I think in our personal lives, we probably all use Google all the time. I know I use it multiple times a day. And there seems to be a tendency amongst people to not want to admit that they use Google search at work. And I don't really understand that. I think if you can learn more, why not? And I'll start with a little story. When I first joined Aiimi, I'd only been there a few weeks at the time. And I sat up in the office and I looked at one of our senior developers and I said, oh, how do you do this thing? And looking back, it was probably something fairly trivial. And he kind of looked up at me and he said, well, have you Googled it? And I thought, of course I've Googled it. Like, it's the first thing I did. And he looked at me and he said, but have you Googled it properly? And I thought, what do you mean? Of course I've Googled it properly. And he replied to me, he said, if I Google it right now, will I find the answer at the top of the search results? And I thought, maybe I'll give it another go. So off I went, and that day I learned a valuable lesson that actually being able to Google things properly is a skill. There is an art to it. And I think what it's about is it's about our desire to find new information and be able to target that in the right way. So I'm going to talk a little bit about search in general. Called it search through the ages. I don't think it's always been called search, but as I've said, humans have a tendency to want to find new information. We've also got a tendency to organize information. We organize things all of the time. And search is doing exactly that, but from a technology perspective. So if we think about things like the library system, so libraries have been around for centuries. They're just a way of organizing information. And in fact, the Dewey Decimal System is a system that's still used today. We categorize books into 10 top-level categories, and then we divide them into further subdivisions that make logical sense to us as humans to find what we want. In a similar sense, we've got the phone book, the Yellow Pages. This is for business contact information. Again, we break businesses down into categories, and then we order them by alphabetical order. I think that's probably why we're called Aiimi, so that we're near the top of the phone book, although it's maybe less relevant today. Moving on, you've got encyclopedias. Through time, encyclopedias have been a way of cataloguing knowledge and information so that we can find it through categories and volumes and things like that. And when we start to think about the technology world, we get people like these guys. Does anyone remember the 118 advert? When these came out, there was actually a service where you could text them a question and somebody would text you back the answer. And I think that was revolutionary at the time, although at £3.50 a text, I don't think it was ever destined to last long. And then we got this guy, and I'll be honest with you, as a kid, I asked this guy loads of questions. I won't tell you what they were, but there were plenty. And as we move around to kind of the modern day, we get good old Google search, and so popular it's not just a search engine, it's also now a verb. So yeah, I think that shows the journey that we've come on. And if you think about what's changed throughout those systems, other than our expectations, I think as humans we're horribly impatient, and therefore we've got a desire for bigger and better and faster. But the first thing I think has changed is the sheer amount of data that we have. So data volume, there's more information than there's ever been before, and actually that information's growing all of the time. So how can you possibly keep on top of that? And search engines try to do that for us. We've got search speed. I talked about a desire to have information more quickly. We're an impatient species, and actually the technologies that we now use need to work quickly and give us the answers we want fast, otherwise we'll move on. And lastly, and probably most importantly, is misinformation. I think in our world that combines big data and fake news, you need to be able to rely on the technologies that you use to give you accurate, correct information at the first time of asking. So I think all of that boils down to this question, and that's why do we do search? And I think there are three key reasons, and the first one is probably the most obvious. This is the one that you use Google for all the time. It's to find out something that you didn't know before. We all do this. We have a question. We want to know the answer. These are kind of like the known unknowns. We know we don't know it, but we know we can find the answer. The second one, I actually think is more important, and this is to confirm something that you already know. So you search for something, you already know the answer. In fact, I use this one regularly to win arguments with my younger brother, and it serves me well. And the third reason is to find new approaches to something that you already knew, and I think this is paramount in sort of the technology world, where technology moves so quickly that if you don't search for new techniques often, you'll probably be left behind the curve. It's really important. And I said there were three reasons. There's actually a bonus one. And this one relates to when you get reason 2 wrong. So when you search for something that you thought you knew, and you actually found out you didn't know it at all. It's quite a painful moment, but a really valuable learning experience, I think. So that leads me nicely onto this quote, and that's that a junior data scientist Googles things around 60% of the time, but a senior data scientist Googles things more than 95% of the time. And you might think, really? But actually, it goes back to that previous reason, to be able to confirm knowledge, to be able to find new approaches. And as I've sort of moved through my career, I've noticed that I've done this more and more. In fact, my confidence in myself to check my own knowledge, to check my answers, and to strive to be better has grown as I've kind of developed. So when you're using a search engine, you're going to get hundreds, thousands, millions of answers, normally in sub-second. And how do you go about choosing which answer is the right one? Well, if you're anything like my mum, you probably click on the top link. You probably ignore the fact that it's an advert. And to be honest, in your personal life, you probably do pretty well out of clicking on that one. But we're not talking about in our personal lives, we're talking about in technology, we're talking about at work. If you're like me, and most of your searches concern something like, how do I do this thing in Python, or which setting do I change in Elasticsearch, you've probably got a way of picking the answer that you're most interested in. Has anyone heard of a little website called Stack Overflow? Okay, frequent users, I'm definitely one of them. You can kind of bet that if Stack Overflow is on the search results, then that's probably the link I'm going to click on first. So I've talked about how you might do search wrong, but obviously the point of this is how do we do search better? And the first thing is one of my massive pet peeves. I see people do this all the time, and that's to include the answer to your question in the question, okay? Here's an example. If you Google, is Python the best programming language, which I don't disagree with, but you will find articles that tell you that Python is indeed the best programming language. And again, this is one that my mum does. So she'll read something, normally on Facebook, and it'll say something like, hot bath cures COVID. And she'll go to Google and she'll type that in. And lo and behold, she will find articles on some dodgy website somewhere that tells her that hot baths do indeed cure COVID. Spoiler alert, they don't. And actually, search engines are getting better at this one. They're constantly scanning search results for misinformation, and they are actually helping to remove that from kind of the public domain, which is good. But the point kind of stands. The second thing is to use context, and I see people not do this all of the time. If you want a tutorial, ask for it. If you want that tutorial to be a beginner's guide, say that. And if you want the documentation, make sure that that's what you're asking for. It's a really simple thing to add to your query, just to add the context in which you want that to be returned. The next one is to know when to be specific and to know when to generalize. And again, this is one that I see done badly on a daily basis in the programming world. And the best example I can give is with error codes. If you take an error code from some code that you've written and you copy and paste the exact error code into Google, you're probably not going to find quite the right answer because the error code will be specific to the code that you've written. And in that case, there's an opportunity there to generalize, to understand what the wider problem is and generalize to that. Saying that, if you take a long error code, actually sometimes it pays to be specific and take the right part of the error code and really target your search to what it is that you're after. So understanding when to be specific and when not to be is another really important thing. And my fourth point, and this is the last one I've got for this slide, which is understand a little bit about how search engines will use your query. So if we think about all good search engines, we'll probably have a notion of stop words. And those stop words are the little interconnecting words that we use to make full sentences in natural language. But to a search engine, they just add noise, so get rid of them. The other thing to consider on this is that actually you need to think a little bit about how the search result might contain the information that you're looking for. And again, I'll give you an example. So if you were to be in your car and you broke down and you'd got a flat tyre, you might ring your breakdown recovery service and you'd say, I've got a flat tyre. And the human on the other end of the phone would know that what you actually meant was, can you come and fix my tyre or tell me how to fix it or whatever that might be. But actually, if you put I have a flat tyre into Google, you're more than likely going to find links to forums where other people are complaining about the time that they too had a flat tyre. And that's not really what you're after. So if you think about how the result might contain the information you're looking for, you can really start to tailor your search query to find that information itself. And finally, I promise you some tips and tricks, and I think these are small things that you can put into your everyday Google search that will really start to improve the way that you do search, improve the way you find information, and hopefully get you to your answers quicker. So I'll start from the top, and the first one is using double quotes to give you an exact match. You can use this for your full search query or for part of it, and it's largely useful when you already know part of what the result might say. The second one is using the asterisk as a wildcard. Again, this is really useful for when you know part of what the result might be, but you actually don't know something that might exist in the middle, and you actually want to wildcard that part of the search. This is my favourite. We've already established that I'm a big Stack Overflow advocate. Actually, if you use the site website prefix, you can limit your search results to only the site that you're interested in. I do this one all the time. Site, stackoverflow.com, type your query in, bosh, you're getting Stack Overflow. This one's another really powerful one, and actually this is the kind of thing that you might use on your second or third Google search when actually your first search hasn't returned the thing you're after at all. In fact, it's returned that in a completely different context. You can use this minus sign to exclude words from your Google search to make sure that your second search is removed from kind of those first things you weren't interested in. This is a new one, and I actually learnt this whilst I was putting this presentation together. I've never used this before, but again, even I'm still learning. And that's to use the double full stop to search between a range of numbers. This is really powerful for when you're looking for an answer in a range of years, for instance, or something like that. And finally, as a programmer, I use logical operators all the time in the code that I write. And actually, I can do exactly that in my Google search. So use operators like and or, you type them in capitals, you can combine those with brackets, and you can build fairly complex logical statements from that. So yeah, all of these are really easy to start using. If you combine them with the things I talked about on the previous slide, where it's just adding a little bit of thought into what you actually type into Google, you can start to build some really, really powerful searches. And I think that's all I'd got to say to you. So hopefully you found that interesting. Hopefully you might have learned something. Sorry for forgetting my lines halfway through. And if you too are interested in the art of Google, please come and have a chat with me after this, and thank you for coming.
That was quite an interesting one because, yeah, I mean, in terms of search, it's something that we take for granted and we use it every single day. But to be able to use it much more effectively like that is super helpful. So thank you very much for sharing your insight on that. Okay, so now we've got the thing that you guys have all been waiting for, pizza. It's just arrived. So we're going to go straight to that in about a minute or two. But I just want to start wrapping things up here and just saying thank you very much to all of the presenters and the speakers today. Thank you very much for you, the audience, who've come here as well and attended in person. It's really great to see everybody back here. And I want to make sure that we get more and more people coming forward as well, offering either to do speaking slots or wanting to do talks themselves, or trying to get their companies involved as well with what GDG is trying to do. Okay. And incidentally, like I said earlier on, GDGs are a funny thing because sometimes you don't necessarily know it, but connections happen as a result of them. It may be that it might not be with this particular chapter, but it might be with another chapter around the country. And those are times when you make the connections, network clicks, and then all of a sudden magic happens. You either get a job or you meet somebody that you want to partner up on a project with or whatever, right? This is the time and this is the place to do it as well. So please, definitely don't be shy. You know, I've seen a few faces here that I've seen, you know, up at DevFest as well. So it's great to see that, you know, everybody's kind of coming back and sharing the connections that they have as well. Okay, so I'm going to wrap things up and say thank you very much again, finally, and pizza time. Thank you. Bye.